Assalamualaikum and hi everyone. I'm Cikgu Yasmin and today we're going to talk about, at the end of the lesson, you will be able to describe matter briefly and explain the changes in the states of matter. Today, students, let's explore a virtual reality program called ViaTIV, and we're going to explore states of matter using that particular program. Okay, so let's go. Okay, students, let's explore ViaTIV, using states of matter. Okay, you can see in the middle chamber, there's solid, there's liquid, and there's also gas. Okay, students, what state of matter can you see now? Yes, it's solid. Okay, let's hear the explanation about it.
The particles in solids are packed very closely. There is a very strong force of attraction between these particles. This force binds the particles together. The particles in solids, though fixed in a particle position, can vibrate at their fixed positions. Thus, solids have a fixed shape and volume.
Okay, students, can you recap? The arrangement of particles in solid is closely packed. So the forces of attraction between the particles are strong. The particles are vibrating and rotating at a fixed position. And we can also say that solid has a fixed shape and volume. Okay? Alright, let's explore the next states of matter. Let's hear it.
Whereas in the case of liquids, the space between the particles is almost the same as in solids, but the particles of liquids are free to move. However, the particles in liquids have a force of attraction between them, but not much energy is required to break this force. This is why liquids have a fixed volume but not a fixed shape.
Okay, students, let us recap. The arrangement of particles in liquid is loosely packed, and the forces of attraction between the particles are weaker than solid. Less heat energy is needed to break the forces. The particles of liquid can move but not freely. The particles of liquid has fixed volume, but it will follow the shape of its container. Okay, students? Alright, let's move on to the third state of matter.
Like liquids, gases are also fluid and can flow in any direction. Gases take on the shape and volume of the container they are kept in. The particles in a gas have a high amount of energy. This makes it very easy to break apart the gas particles. Hence, they cannot hold their own shape and volume. Instead, they take the shape and volume of the containers they are kept in. You have completed this activity. Select OK to return to the menu and continue to the next activity.
Okay, students, let's recap. The particles in gas are very far apart. The forces of attraction between the particles are very weak. The particles can move freely and at random. The particles of gas has no fixed volume and no fixed shape. Okay, students? Can you recap on your own? Alright, that's very good. Now, let's explore more activities on the states of matter. Okay, students, now let's look into particles in different states of matter. We will be able to see what happens to the particles in certain states of matter when the temperature of the matter involved is changed drastically. Stay tuned. Ooh. Now, students, let's see. This is like a game. So it says here, go inside the chamber by using the forward direction on your controller and observe the different states of matter. Okay, let's see. Let's go. Okay, I'm almost reaching the door. Oh, that is... What is that? Yes, it is water. Okay, let's go nearer, nearer, nearer. Okay, can you see that now? Yes. All right. This is the structure of water particles. Water exists in a solid state at 0 degrees Celsius. As the temperature rises, it converts into liquid, and at 100 degrees Celsius, it boils and converts into gas. Now, students, let's observe the properties of the particles of a solid, liquid, and gas at different temperature. The example given today is water. The formula of water is H2O. Okay, students, now let's see. What is the state of matter of water at this particular point? Okay, if you can see that all the particles are connected to each other. Oxygen, hydrogen, they're all bonded to each other. Okay, so if they're bonded to each other, and if you can see here, they're like vibrating at its fixed position, they exist as solid, right? Okay, so what's the temperature? It has to be 0 degrees Celsius. Okay, now let's see what happens when we increase the temperature. Okay, there's a slider. Drag the slider to change the temperature and observe the motion and intermolecular spaces between the particles. Okay, students, can you see that the particles are moving and vibrating at just fixed position at 0 degrees Celsius? I'm going to increase up to 20 degrees Celsius, and you look, it's vibrating even more and it's breaking up. Okay, so it's now moving more vigorously, but it's still like, it's still fixed. Now, this is actually the state of liquid. Liquids have a fixed volume but no fixed shape. The spaces between the particles of liquids are almost the same as in solids. The particles of liquids are free to move. The particles in liquids have a force of attraction between them, but not much energy is required to break this force. Okay, I'm going to move further. If I drag it to 40, it's still liquid. I'm going to drag it to 60, still liquid. 80, you can see some of them has like, move away from each other. Okay, I'm going to go close to 100, and they are moving freely at random. Now, this is the state of gas. So gases can flow in any direction, and gases take on the shape and volume of the container they are kept in. The particles in a gas have a high amount of energy. Look at them. You see the particles are moving here and there, so it's so lively. Okay, gas particles have large intermolecular spaces between them. Okay, now how cute is that? Okay, so that'll be the end of this part. Okay, we have another part. All right, students, it's time to assess your knowledge. It's a Q&A session. Okay, students, so this is the assessment section. Okay, we're going to look into these 3 chambers, okay, and see what happens in each chamber, okay, and answer some questions. Oh, there's points to be earned, but that's not really a matter, okay? Alright, I gotta move inside any of the highlighted chambers using my controller and then observe the state of matter and answer the questions. Okay, so I'm gonna go with the middle one, okay? It's the first one that I'm facing. Okay, let's go. Open the door. Oh, okay. You see that? There's some particles of state of matter. Okay, look at them. Oh, all right. They can move, but they're not so freely. They're not really like, in fixed shape. Okay. Oh, there's a question now. Which state of matter is exhibited by these particles? Is it A, solid, B, liquid, or C, gas, or D, none of the above? Which one is it? Okay. It's not vibrating, but it's moving, but it's not so freely, so it cannot be solid, it cannot be gas, so I think it has to be liquid. What do you think? Okay, yes, okay. I think most of you agree with liquid, so let's choose. Yay! The answer is correct. It's B, liquid. Okay, try to move between the particles. Okay, let's move between the particles. Oh, you can easily move between the particles. Yes, I can do that. Oops, there's a question. Okay, question number 2. Why are you able to easily move between the particles? Is it A, the particles have a lot of room in between them? Or is it B, the particles are loosely packed? Or C, the particles are tightly packed together? Or D, the particles move randomly? Which one is it, students? Yeah? Okay, let's go with loosely packed. No? A lot of room because I can move through it? Maybe. Okay, let's try A. Let's see what happens. Don't make me lose my score. Oh my goodness. It's not A. I'm gonna go with my answer, which is loosely packed. Well done. Okay, but I didn't get the score. Okay, but that's okay. Okay, observe the motion of the particles and answer the question. Okay, let's see. All right, that's how they're moving. Okay, let's look at the question. Which type of motion is exhibited by these particles? Is it A, the particles move randomly with a high speed and try to spread out in every direction? Or B, the particles move randomly but in a fixed volume? Or C, the particles are fixed at their position? Or D, the particles vibrate at their fixed position? Okay, they're not fixed. They can move. We can walk through them. They're not vibrating. Moving randomly with a high speed, no. We have to like push through it. And I think it's B. Okay, let me choose the answer this time. I want to get the score. Okay, the particles move randomly but in a fixed volume. Yay! That's right. Okay. Move outside the chamber by using my controller. Okay. So goodbye particles. Okay, let's go. We're just gonna move through it. Oh, that's fun. Okay, let's move to the door. Okay, it's opening. All right. Move inside any of the highlighted chambers by using the controller, then observe the state of matter and answer the questions. Okay, students, I'm going to enter chamber number 2. Let's look what happens inside. Oh, this particle seems different. Okay, observe the particles of the state of matter and answer the question. Which state of matter is exhibited by these particles? Okay, this is our question number 1 from this chamber. Is it A, solid, or B, liquid, or C, gas, or none of the above? Okay. They look like they're closely packed and they're just vibrating and moving at a fixed position. What do you think, students? A, solid. Okay, that's the answer I have in mind too. Okay, let's choose A. Yes, you're right. Okay. Try to move between the particles by using the controller. Okay, let's crush to them. Oh, we cannot move through them. We can't. Oh my goodness. Okay, question number 2. Why are you not able to move between the particles? A, the particles have a lot of room in between them. B, the particles are loosely packed. C, the particles are tightly packed together. And D, the particles move randomly. Okay, I think the answer is very obvious. It's C, the particles are tightly packed together. Okay, let's choose that. Yes, we're right. Okay. Observe the motion of the particles and answer the question. Okay, I think this will be our question number 3. Which type of motion is exhibited by these particles? A, the particles move randomly with a high speed and try to spread out in every direction. B, the particles move randomly but in a fixed volume. C, the particles are fixed at their position. And D, the particles vibrate at their fixed position. Fixed at their position, vibrate at their fixed position. Which one is it, students? Is it C or D? Because it can't be A or B. It has to be either C or D. Which one is it? So close. Okay, let's go with, yeah, D? Okay, the particles vibrate at their fixed position. All right. Yes, well done. Okay, good job. Move outside the chamber by using your controller. Okay, we have to leave this chamber now. Right. It's like playing a game, maneuvering. Okay, I'm outside now. All right. Move inside the remaining highlighted chamber by using your controller. Then observe the state of matter and answer the question. Okay, so that's just one more chamber to explore. Okay, students, I'm here, so let's go. Okay, students, I'm here now, so let's go. Open sesame. Oh, that's so cool. Okay. So you see the particles of this particular state of matter, and we get to answer some questions, and you look at the particles, it's so happily moving. Okay, question number 1. Which state of matter is exhibited by these particles? A, solid, B, liquid, C, gas, and D, none of the above. I think it's pretty obvious, yeah? It is C, gas. Okay. Correct. Well done. Okay, try to move between the particles. Obviously, we can move between the particles. Observe that you can easily move between particles. Yeah. Oh, there's your question number 2. Why are you able to easily move between the particles? Is it A, the particles have a lot of room in between them? Or is it B, the particles are loosely packed? Or C, the particles are tightly packed together? Or D, the particles move randomly? Easily move between the particles. How can we easily move between the particles? Definitely can move because there's a lot of room in between them. But D, the particles move randomly, which is what's happening. Look at the particles moving here and there. Okay, but I think it's because of A. What do you think? Or is it D? Want to try D? Okay, let's try D. Try again. I should have gone with my answer. It's A. The particles have a lot of room in between them. Okay. Observe the motion of the particles and answer the question. Look at that. Let's just go one nice around. Okay, there must be a question coming. Yes, question number 3. Which type of motion is exhibited by these particles? Okay, is it A, the particles move randomly with a high speed and try to spread out in every direction? Or B, the particles move randomly but in a fixed volume? Or C, the particles are fixed at their position? Or D, the particles vibrate at their fixed position? Again, the answers stood out. The particles move randomly with a high speed and try to spread out in every direction. Is that what you're saying? Yes. Okay, maybe. Okay, let's try that. Correct. Well done. Okay. You have completed the assessment. Here's your score, 77%. You scored well. Well done, students. So, students, we have come to the end of our lesson for today in states of matter. So, I hope you can name the 3 states of matter, which is solid, liquid, and gas. And students, you can explain the arrangement of particles of all 3 states of matter, the forces of attraction between the particles, the amount of energy needed to break the forces, and the movement of particles, whether at fixed position or moving at random or can move freely, and finally, the volume and the shape of all 3 states of matter. Okay, students, so see you again in the next lesson. Bye-bye!